Now let me illustrate the use of Wally plot from the package mess. But first of all, I read in the data like this. That's the height example data. We're going to check for a normality by the QQ norm, the normality plot, by this use of the find Wally plot, kind of simulation-based hypothesis testing kind of way, without really doing the hypothesis test, but just by looking at it visually, by a little bit of simulation. So this is where you would need to install the package mess, either then by writing install packages mess, or by clicking install packages in your RStudio menu, and you can install the package. I won't do it now because I already installed it. Then you should just see these lines of code here. The data is in X, so if you call your data X, you can just copy this line of code and you can get the following done. Let's see if it works first now. Like this. Now you get something on your right hand in the plot here. I'm going to increase it a little bit for everyone to be able to see it. We have those, and at the same time, actually in your interactive window, it says, let me just show that before we do it, it says hit enter to show the original plot. So one of these 9 plot is the original QQ plot with the QQ line, but the other 8 are QQ plots from real normal data. So we simulate normal data. So 8 of them are as normal QQ plots could be with this number of observations, and one of them is yours. So the find Wally issue is that you look at those 9 plots and you make the decision which is the most odd looking one, which one deviates the more from the line, on which plot are the points the mostly deviating from the line. That's what your first task. You do this. I would say one of the 2 bottom ones down here, if I should really point at one, I would go for the bottom left here. The bottom left plot is my Wally now. I think that's the most deviating from normality, if I look at it. Then let's see. That's the thing now. You don't know which is yours. When I press enter, the program tells me which one is yours and which one, and the other ones are random normals. So I have to do it the right place. Here I am. I go enter. Whoa. So your data, the height data, was actually not the one you pointed out. So the red one here, that's the height data. The other 8 ones are truly normals. So my conclusion is, as the one I pointed out to be the apparently most deviating from normality plot is actually a true normal. And since my plot is less deviating than this one, my conclusion is that my data could easily come from normal distribution, right? Because my data is not deviating more than the normals. So I accept the normal assumption here. I couldn't reject the normal assumption based on this sort of find Wally version of doing normality assumption. So that's the way it works with this. Thanks.